Hi, I'm David Towers, and I'm presenting on behalf of myself, Matthew Forshaw, Stephen McGaugh, and Amir Attapur Alpagui for our submitted paper, Long-Term Reproducibility for Neural Architecture Search. So first, a bit of background. So NAS aims to replace manually designed neural networks, and this has been the goal since the first NAS algorithm. To achieve this goal, it needs to be generalizable. It needs to work just as well on one problem as it does on another. This means it needs to be reproducible. We can't reproduce it, we can't apply it to a new problem. Unfortunately, many of the NAS approaches that we've encountered are not easily reproducible. This hinders further research as it makes it harder to run all the algorithms and generate results. It also hinders its use in real-world applications. If we want to replace manually designed networks, we need NAS to be simple to use. There are several problems that can occur with NAS approaches. These include missing documentation, inaccurate documentation, major bugs that prevent entire sections of the code from running, and missing or inaccessible dependencies. Not all of these are the fault of the author, but a lot are avoidable. To encourage more reproducible practices, we developed a checklist for software artifacts in NAS. We also show how 4 existing NAS approaches perform on this checklist. The checklist covers areas such as code stability, good documentation, ease of running, standardization, and future-proofing. Future-proofing is one aspect we have not seen talked about elsewhere, and we suggest a potential solution is containerization. So using containerization tools such as Docker or Podman, we can improve the reproducibility of a NAS algorithm. With such tools, we can build the environment from a specification file, which will install any dependencies automatically and ensure they have the correct version. Or we can store the image as a zipped file, which will include the dependencies, and this means that even if they become inaccessible, the code will still work. If the code is developed inside the container, the environment will be the same as the author's, which is good for reproducibility. And as these tools use virtualization technology, similar to that of a virtual machine, they will be basically using the same operating system. If you have any other questions or want to know more, please come visit us at our poster.